It's Andy here. Alright, so I finally finished all of my modifications. So this is now a single pole double throw regular house light switch that's used for, like, where you have two light switches controlling one light bulb. Well, you just take those ones. So each one has those. So you can watch my last video. I talk about this quickly. But I've made the modifications I said I would. I've got an on-off switch that I've added to the back here. Let's see. So that on-off switch controls this charger I bought off eBay. This is a 29.4 volt lithium-ion battery charger. And I just held it in place using some simple metal clips. Screwed in down through into the wood. So that's been properly installed. You can see, and I soldered it down in, it's hidden way down in there, so I had to take this all apart. It's basically soldered into these two contact points, the live and the neutral of this. So it works out really well. Let's see if you can see that. So I don't think you can. No, well, I can see it's flashing for some reason. There we go. So it's green because I turned it off. I flip it to on. The red wire goes to the off position, so that when it's off, it allows it to charge. You can see it's red, so it's that means that it's charging. See, 29.4 volts. And then when I flip it off, goes down to 29.3, so pretty good. So for some reason it makes this really annoying clicking noise, which is most likely one of these guys switching on and off, because I was thinking of adding a 24 volt or two really small 12 volt lead acid batteries in here, the airtight ones, just to satisfy this circuit, because it doesn't like these lithium-ion batteries for some reason. So I'm not sure. So yeah, so that was the main thing to get done, was mounting this in here and switching this out. Everything else works really well. I'm pretty happy. I've got this 12 volt solar panel. I just put it here just for looks. It's been cracked and damaged over here, but just to kind of show, like, I could get, like, preferably a 24 volt solar panel and just put it right there, and then put this really cheap solar charge controller here, and I could hook it all up. So yeah, I could do that if I wanted. It would work out really well. But, not going to worry about that. As I mentioned in my previous video, I've got 3S, 4S, and then 7S, so I can play around and do some testing with that, which I'd like to do. It would be fun. At 21 volts, the UPS turns off. This BMS it's always, the negative is connected, and then when I flip it to BMS, then it goes from here through the BMS and then to the UPS. I just do that for testing. This wouldn't be necessary at all in a final version, but this board is designed for testing and experimentation. I found that when the UPS is running, for some reason there's a feedback loop of 28 to 30 volts AC that when you touch right there, it does electrocute you, which is really annoying. I'm not sure. So in the future, I'd just remove this entire system and replace it with, a proper pure sine wave inverter like this guy here, this Go Power. It's hidden behind here. Can't really see it well, but it doesn't matter. So I wouldn't recommend using a UPS. It would be better to use a pure sine wave inverter, and then use a double pole, double throw relay, like a large industrial relay with it, and that would do exact same job as a UPS. And you can get these for free. These UPSs, you can get them for free, and then use the back plate. It's pretty useful, and you can use the whole back plate to connect up things, and then just use your pure sine wave inverter in conjunction with that. So yeah, that's it. It works really well. This BMS is pretty terrible. Not happy with it at all. For some reason it's got a 1 volt difference. Doesn't explain why. See if I go to BMS and then switch there. Didn't do it that time. That's strange. Well, normally it drops by 1 volt. It did in my last video. I'm not sure why it's doing that now. So, oh well, no big deal. But anyways, yeah, I'm pretty happy with this double pole single throw switch controlling. You can see it. Oh, of course, it just decides to completely die. It's weird. So right now it's green. Switch there, now it's red. And then I flip this off, and then it's off. So power's cut completely. There's no negative. There's no neutral, and there's no live wire connected to this, and it's just the negative that's connected to here, because it's right here actually. This wire here is the negative to the charger. So yeah, I've got this and this guy just sitting here just for show for now. One person asked if I was going to take away the whole casing and just have the circuit board there. No, I'm gonna put the cover plate back on. I did have it on before, but I took it off to make this video so you could see it. I'd rather have the case on it. See, it looks a bit better with the cover plate and this guy on, but I'm not too worried since this is for experimenting. This isn't a final product. This isn't something you'd sell to someone. This is something that I use for just testing certain things that I want to test and look over. And it'd be good for my computer or something else. I'd need a better UPS though, because this one's pretty lackluster. It's a small one. It can only handle like 15 amps at most, I think. I don't know how many watts that is. It claims 800 watt hour. WA's watt amps or some stupid shit. VA volt amps. It can't. It's a piece of junk. But it's good for testing, so I don't mind. Just the shitty part is the feedback of that electrocutes you if you touch it. Anyways. So yeah, I hope you like that. I don't like these brackets that I made for it. I did them really quickly. I'll eventually probably make better brackets to put on here, but in reality it doesn't matter because I don't like this thing anyways. I'd rather do away with it and have a better system. So I'm not really worried about that at all. So yeah, I wanted to go through some comments. So yeah, it was DIY in the Ghetto that asked if I was going to keep the case or not, and he was suggesting that there'd be a problem, like the humming noise would be amplified by the plastic casing. But like I said, this thing's a piece of junk. I don't really care. It's not a final product. But thank you for asking about that. Average Joe said, because I mentioned my last video about using a wind turbine, and Average Joe made a video about this. If you find a Fisher Paykel, LG, or Samsung washing machine, they have really good permanent magnet PMA motors. Yeah, permanent magnet motors. So he suggested just finding one of those instead of building my own permanent magnet motor. But it would be kind of fun to make your own. But yeah, you can look up Average Joe's channel, and he does have a video that talks about building your own wind turbine using it. I'm very certain I'll check that out after I upload this video and post a link. So Eric asked, or actually he had an update saying that for his system he has a 6S, instead of a 7S, but he's going to add the 7th battery onto. He's going to use Ford C-Max cells, and yeah, that'd be interesting to see how that goes. Yeah, he has like Chevy Volt 6S battery pack, so he has to tackle that problem. And Boss Jan Trankar, he talked about he has a Make Sky Blue, but the problem is that I was asking is I need a solar charge controller that can control the current output to the batteries, and actually none of them can actually, like, you can't set in any of these MPPTs how much current flow to send out to the batteries. So someone suggested to me, actually let me check. So Marek, he suggested to just use a CCCV controller, which is constant current, constant voltage controller, which is actually what this guy here is. All right, that's a CCCV. So he suggested just take one of these, and then you would put it, in here. So yeah, I looked it up, and I'm gonna do that. So thank you. I'm gonna look into that. I already picked one out actually. It was pretty cheap, but I'm trying to remove as many modules as possible. But not a big deal. In the future for this guy, I think I'd rather just remove this whole unit and then replace it with a tiny little circuit board that balances the system, because I don't like how big this guy is. He doesn't do enough to justify his size. So yeah, also he suggests using MPT 7210A, sorry. That's that one that's just a boost converter. It's not a real MPPT, it's just a boost converter. So it's not even a good option. Like, it's $50. I looked into them. There's tons of videos of people who have bought them and tested them out, and it's not good for what I'm doing. But it is an interesting device to play with for its price range, which is good. And I'm also looking at TP4056 chargers, which are just basically really shitty, like, battery chargers. So when these are only $30, I would rather just, you can buy a ton of those things. Those TP4056s are really cheap. You can buy a whole bunch of them, and then you just buy these battery holders here. You can buy a whole ton of them, but honestly, for $30, the LII 500 is just a much better situation for you to put up with or deal with. Like, this is much better for me anyways. I'd rather just stick with it. I might be wrong, but like, I know you can get a ton of these guys for really cheap, but if you're building a giant system that charges up batteries and tests them, then this would definitely be a good option. But I'd rather just get the LII 500. It's just a lot less. It just works right out of the box, but it depends on what exactly you're doing. But yeah, anyway, so I got that all done. This video is already going way too long. I still haven't worked on this at all. I still need to get an on-off switch for it so I can, solder or spot weld these batteries without blowing a hole through them. So anyways, yeah, let me know what you think. Thanks guys for your comments. Thank you for your subscriptions. Keep sending those comments. I really appreciate them. Let me know what you think about this guy. Don't judge me about the solar panels. It was just put there as like, show that I have room for a solar panel and charger. So anyways, hope you like it. Thanks. Have a good night. Bye.